Okay, let's talk about dilutions real quick. So again, we're going back to Unit 1, Section 3 homework. And let's go ahead and cover, let's do number 2 because it seems to be pretty simple. So this is number 2 under dilutions on Unit 1, Section 3. So it says you just added 60 milliliters to a tube that contains 1 deciliter of water. What dilution did you make, and what will be the dilution factor? It'd be kind of nice to know what that 60 milliliters of stuff was. Sorry about that. Again, we can't add milliliters and deciliters very easily, so it's going to help us if we convert one to another. So let's go ahead and take our deciliters. Let's see, how about deciliters to milliliters? So I've got 1 deciliter. And I'll be honest with you, I don't do real great with a conversion of something like deciliters to milliliters. It's kind of a weird number most of us don't remember. So I might go straight to liters, and then I can go from liters to milliliters. So I know that there are 10 deciliters in a liter, and I know that there are 1,000 milliliters in 1 liter. So just the way the fraction's set up, the deciliters go away, the liters go away, and I'll actually be left with milliliters. I do the math straight across, so I get 1,000 on the top, and I get 10 on the bottom. So I know that 1 deciliter is equal to 100 milliliters. So I can go back to the original fraction here, the original problem that says we added 60 milliliters to what I know now to be 100 milliliters. And it's saying what is the dilution and what is the dilution factor. So remember, when we're doing dilutions, we're going to express these as a fraction, like a 1 to 4 dilution. But a dilution like that, the 4 is always total parts. So 60 milliliters, whatever we started with, plus my 100 milliliters of water gives me 160 total milliliters. So now I can look at this as a 60 to 160 dilution. However, we don't typically work in numbers like 60 to 160. So we are going to convert this or simplify the fraction. So I can start by hacking a 0 if I want. So I can end up with a 6 to 16, where basically I divided the top and the bottom by 10. Well, I can reduce this even further and divide both to 2. So I end up with a 3 to 8 dilution. Now 3 to 8 dilution is looking a little bit better, but if I need a dilution factor, what I need is I need a 1 on the top and then some sort of number on the bottom. Because that number on the bottom, as long as there's a 1 on the top, is going to be my dilution factor. So what I need to do is I need to get a 1 on the top here. So if I divide the top by 3, I end up with 1, and then I divide the bottom by 3, and I end up with 2.66.